binomial theorem for negative and fractional index, fraction or rational index, fractional or rational index. You know very well, that is fraction means p by q form, negative. So what we know from binomial theorem is, binomial theorem says that 1 plus x or 1 plus x 1 to the power of n, it is nc naught x to the power of n plus nc1 x to the power of n minus 1 plus nc2 x to the power of n minus 2 plus so on, ncr x to the power of r and so on, LCM x to the power of NCM 1 x to the power of n minus 1. Let us write another way of this. For convenience sake, I'll write like this: NC naught C1x C2x square CR x to the power of r and NCM x to the power of n. There is 1 plus x whole to the power of n. X plus 1 whole to the power of n, 1 plus x whole to the power. There is a binomial theorem, 1 plus x, no restriction for x. N is a positive integer, then this holds true, isn't it? Now, if you open NC0, NC1, NC2, NCR, NCR, that is, NCR is n factorial by n minus r factorial into r factorial, isn't it? So, if you write the notation for NCR in terms of n factorial by n minus r factorial into r factorial, and if n, look here, this is 1 plus x whole to the power of n. N may be negative integer or fractional index. Fractional or negative. X, 1 is as itself. 1 as itself. And x, if you take x, if modulus of x, that is the numerical value of x is less than 1. Numerical value of x, absolute value of x is less than 1. That is, the range of x is, if what we say, if modulus of x is less than 1, minus 1 is less than, x is less than 1. There is a notation for modulus of x less than 1, isn't it? So, if modulus of x is less than 1 and if n is a negative or fractional index, then nc0 is 1, nc1 is n, nc2, n into n minus 1 by 2 factorial x square and so on. NCR is n factorial, that is n into n minus 1 into n minus 2 into so on, n minus r plus 1 by r factorial x to the power of r, so on, n factorial, it tends to infinite. It's an infinite series. Look here, what is the NCR? Just how to look into this value. What is NCR? NCR is n factorial by n minus r factorial into r factorial. What is n minus r factorial? N minus r into n minus r minus 1 into n minus r minus 2 into 2, so on, 2 into 1. That is n minus r factorial. What is n factorial? I write n factorial as n into n minus 1 into n minus 2 into so on, n minus r plus 1. Next term is n minus r. And then so on, I can write that so on as n minus r factorial. Now n minus r factorial gets cancelled. Is it 8 factorial by 6 factorial? What we can write? 8 into 7 into 6 factorial. This 6 factorial gets cancelled. That's the way I have to say. 7. There is plus 1. Right. Isn't it? N minus r plus 1. Again, n minus r plus 2. So on, get here. So, NCR is nothing but n into n minus 1 into n minus 2 into n minus r plus 1 by r factorial. So, this notation, this is the formula. If n is a negative or fractional index, open the notations of coefficients, binomial coefficient of 1 plus x whole to the power of n. It tends to infinity if modulus of x is less than 1 and n is either negative or fractional index. Is it clear? So, here, this is the important condition. here the general term, here the general term is nothing but PR plus 1. General term is nothing but PR plus 1. This is first term. This is second term. This is third term. Third term square. There is R means third term means here it is T2 plus 1. Here it is TR plus 1, right? So TR plus 1 is n into n minus 1 into n minus 2 into so on n minus r plus 1 by so on by r factorial x to the power of r. That is the general term in this expansion. Is it clear? Right. Suppose I have to take this, right? Suppose if this expansion, let us move on to this. If this expansion, if 1 plus x is not given, 1 plus x is not given, so then what's given? Then if it is in the form of x plus y whole to the power of n, x plus y whole to the power of n, what do we have to do? It is an infinite series. It's an infinite series. Then x to the power of n into, I have to write 1, isn't it? 1 plus x is taken common. There is y by x whole to the power of n, where modulus of y by x, the numerical value of y by x must be less than 1, or modulus of y is less than modulus of x, or else we say that if modulus of x is greater than modulus of y, if the numerical value of x is less than, sorry, greater than the numerical value of y, if the denominator is greater, then this value lies between 0 and 1. Modulus is that this value lies between 0 and 1. Sometimes its value is less than 1. That's the meaning. So suppose if you take y common, then it is 1 plus x by y. Y is greater than x whole to the power of n, where modulus of x by y is less than 1. When you look into the problem, that's given in JEE mains, if a thing is taken common and it's in the form of 1 plus x whole to the power of n, where that modulus of x is less than 1, then we can apply the formula 1 plus x whole to the power of n as 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on n into n minus 1 into n minus 2 into so on n minus r plus 1 by r factorial into x to the power of r. There is a negative or fraction. Suppose if 1 minus x whole to the power of x is taken, but 1 minus x whole to the power of minus n, 1 minus x whole to the power of n negative integer or fractional part, suppose x is a negative. Similarly, model range is same, modulus of x must be less than 1. This expansion can be written as 1 minus x nx plus n into n minus 1 by 2 factorial into minus x whole square is x square plus so on. We'll get negative here, minus x whole cube. Then n into n minus 1 into n minus 2 into so on n minus r plus 1 by r factorial minus x whole to the power of r. This same thing can be written as minus 1 whole to the power of r into n into n minus 1 into n minus 2 n minus r plus 1 by r factorial to x power r. But I write like this. So up to infinity. What is here? The general term here. Here the general term. You have to learn these formulas. Here the general term is r plus 1. Nothing but n into n minus 1 into n minus 2 into so on n minus r plus 1 by r factorial. This is the general term in 1 minus x whole to the power of n, where n is a negative or a fraction. Is it clear? Right. Suppose we go for n. If n is not purely negative, I take the n is positive, and what is minus n? If n is positive, what is minus n? Here, 1 minus 1 plus x whole to the power of minus n. 1 plus x whole to the power of minus n. I can write like this: 1 plus x n minus n into x plus minus n into minus n minus 1 by 2 factorial into x square. Same. If you substitute, replace n with minus n. Okay. Then this becomes minus n minus 1 minus n minus 2 minus n minus r plus 1 by r factorial into x to the power of r plus 1 up to n. So finally I can write this as 1 minus nx minus, if you take common, that will be added to this, and this becomes positive n into n plus 1 by 2 factorial x square, and then so on. And this becomes, how many minuses are there? X term will be negative here, x cubed term. Minus, 3 terms, 3 negatives will come. Here, second term, x is there, 1 negative will be there, x square, 2 terms, 2 negatives. X power r negatives we have common. So this becomes n into n plus 1 into all are positive, n into n plus 1, n into n plus 1 into n plus 2 into so on. N plus r minus 1, n plus r minus 1. If we take minus common, n plus r minus 1 by r factorial into x to the power of r into minus power r. Minus x, minus once r times, so it becomes minus x whole to the power of r. It tends to infinity. So what we can conclude here? Here the general term, the important formula here, general term tr plus 1th term is nothing but n into n plus 1 into so on n plus r minus 1 by r factorial into minus x whole to the power of r. This is the general term. This is the general term. Similarly, if you consider minus here, 1 minus x whole to the power of minus n. Look here, this minus becomes minus n into minus x. So this becomes 1 plus nx. Here minus x whole square, these two minus, it becomes plus. So n into n plus 1 by 2 factorial x square, all are positive. N into n plus 1 into so on n plus r minus 1 by r factorial. Minus 1 whole to the power of r here, and again minus x whole to the power of r there. Both when you multiply, minus 1 into minus x whole to the power of r, it becomes x to the power of r, so on infinity. So what the general term denotes here means same formula, general term, same value. What you can observe is tr plus 1th term is nothing but n into n plus 1 into so on n plus r minus 1 by r factorial into x to the power of, this is the general. 1 plus x whole to the power of minus n, 1 minus x whole to the power of minus n, 1 plus x whole to the power of n, 1 minus x whole to the power of n. These are the values that is obtained from 1 plus x whole to the power of n, standard form of the binomial theorem. From the standard form of the binomial theorem, 1 plus x whole to the power of n, where n is a positive integer. If n is not a positive integer, you open this notation, open this nc0, nc1, nc2, so on ncn, then it becomes 1 n into n minus 1 by 2, n into n minus 1 into n minus r plus 1 by r factorial, and then this becomes 1. So that tends to infinity if this modulus of x is less than 1 and if n is a negative or rational. Okay. Suppose in the same formulas, you have to learn one thing here is, it may be a fraction. For negative I have written here. For fraction also you have to see what the fraction will do here when n is taken as p by q. Let us say p taken p by q. Look here, 1 plus x whole to the power of p by q. No need to say p and q are integers. So 1 plus x whole to the power of p by q. What is the general form? 1 plus nx means p by q into x, that is nx, and then n into n minus 1 by 2 factorial into x square, so on, and then plus p by q into p by q minus 1 into so on, p by q minus r plus 1 by r factorial into x to the power of r plus so on up to infinity. So just I rewrite this. P by 1 factorial x by q, p into p minus q, p minus q by q I write here by q square, that is x by q whole square by 2 factorial. And similarly, look here, this can be written as p into p minus q into so on, p minus r, p minus of r minus 1 into q, p minus of r minus 1 into q by r factorial into x to the power of r. You have to learn this for IB. What is the general term? In IB, there was the general term, the expansion of 1 plus something x over to the power of 2 by 3, minus 2 by 3, 3 by 4, minus 5 by 4, like that. You have to answer like this. General term is PR plus 1. What is PR plus 1? P into n minus 1 is p minus q into p minus 2q into so on, p minus r minus 1 into q by r factorial x to the power of r is the general term in this expansion. In this expansion. Is it clear? Suppose if it is 1 minus x, if it is 1 minus x, whole to the power of p by q, what happens? The same formula, I can write it as 1 minus p by 1 factorial into x by q. In place of x, we'll write minus x. P into p minus q by 2 factorial into x by q whole square minus x by q whole square plus so on, p into p minus q into so on, p minus r minus 1 into q by r factorial into x to the power of r minus x by q whole to the power of r. Here I wrote something, here x by q whole to the power of r, isn't it? Similarly here also, usually we will do mistakes there, right? So here x by q whole square, here it is minus x by q whole to the power of r, minus x by q whole to the power of r, so on. What is the general term here? Here the general term is this. Here the general term is this. This is the general term. This is the general term in this expansion, 1 minus x whole to the power of p by q. What is the difference here? Here 1 plus x, power is positive. You will get the x by q whole to the power of r, n into n minus 1, n minus 2, n minus. Here it is 1 minus x whole to the power of positive power. P and q are positive, plus p by q. Only one negative is there, alternate negative. So here it depends on the term. So it is minus x by q whole to the power of r. If r is positive, even number, r is an even number, this becomes positive. If r is an odd number, it becomes negative. Okay? Right. Suppose if it is minus p by q, if it is minus p by q, what happens? If it is minus p by q, what happens? Look here. If it is minus p by q, I can drop this. What is the formula for minus n? What is the formula for minus n? 1 plus nx, n into n plus 1 by 2 factorial x square. So all are positive there. So I can write that here 1 plus x whole to the power of minus p by q can be written as 1 plus minus p by q into x plus minus p by q into minus p by q minus 1 by x square by 2 factorial into x square plus so on plus minus p by q minus 1 and all minus p by q minus r plus 1 by r factorial into x to the power of r. So look here, the formula how it changes is 1 plus x whole to the power of minus p by q can be written as 1 minus p into x by q. I can write it as p by 1 factorial. 1 will be there, 1 factorial. This, if we take minus common, this becomes p into p plus q, where it is n into n plus 1. Here p into p plus q by 2 factorial into x by q whole square. And the next term will be 3 negatives will get, so minus x cubed term and so on. Here minus r times minus we have to take common, p into p plus q into so on p plus q into r minus 1 by r factorial into x by q minus x by q whole to the power of minus x by q whole to the power of. So this term here, this term becomes the general term. Here this term becomes the general term. Here this term becomes the general term. Here 1 plus x whole to the power of minus p by q is nothing but 1 minus p by 1 factorial into x by q. P into p plus q by 2 factorial into x by q whole square. So on p into p plus q into p plus r q into r minus 1. R minus 1 into q by r factorial minus x by q whole to the power of r. One negative is there, alternative negative will be there. If both are positive, all are positive. If one negative will be there, alternative negative. If both are negative, I'll write both negative here. Look here. So 1 minus x whole to the power of minus k by q is 1. Minus minus gets positive. P by 1 factorial x by q. Since power is negative, we will get all positive internally. So next one is p into p plus q by 2 factorial into x by q whole square. And then so on p into p plus q into so on p plus q into r minus 1. R minus 1 into q, however you want, right? You can write by r factorial into both are positive, all are positive, so x power r so on to infinity. So which term is negative? The general term. Here this term is the general term. Here this term is the general term. This is for negative and for rational index. This is the method of finding the formulas. So here formulas are very important rather than proofs. So you have to learn 1 plus x whole to the power of n, 1 minus x whole to the power of n, 1 plus x whole to the power of minus n, 1 minus x whole to the power of minus n, 1 plus x whole to the power of p by q, 1 minus x whole to the power of p by q, 1 plus x whole to the power of minus p by q, and 1 minus x whole to the power of minus p by q. This is the formulas that we have to learn for negative or fractional index. Once 1 minus x whole to the power of n is positive here. 1, this minus, due to this minus, we are writing minus alternatively. Formula is n into n minus 1, n into n minus 1, n minus 2, n minus r plus 1 by r factorial. Right. If n is negative, n is positive, minus n is given. 1 plus x whole to the power of minus n, alternative negative will be there. 1 minus nx, n into n plus 1 by 2 factorial x square, n into n plus 1 into n plus 2 into n plus r minus 1 by r factorial minus x whole to the power of r. This is the general term. This is the general term. Here both are set up in the general terms. Here minus minus both negative. So these two minus makes all are positive. 1 minus n is there no nx, n into n plus 1 by 2 factorial, n into n plus 1 into n plus 2 by r factorial, n plus r minus 1 x power. Suppose what is the value of 1 plus x whole to the power of p by q? There is 1 plus p by 1 factorial into x by q, p into p minus q by 2 factorial into x square, so on, p into p minus q into so on, p minus r minus 1 into q by r factorial into x by q whole to the power of r. This is the general. What is the 1 minus x of whole to the power of p by q? This becomes 1 minus p by 1 factorial x by q plus p into p minus q by 2 factorial x square plus so on, p into p minus q into so on, p minus r plus p minus r minus 1 into q by r factorial into minus x by q whole to the power of r. This is the general. Minus of r minus 1. P minus r minus of r minus 1 into q. Suppose if p by q is negative, we will get positives here. Thus are the general terms. Learn all these things. write each and every formula, write general forms once, try at least 2 to 3 times. Then we can learn the formulas based on this.